These are computer simulations of blood flow interacting with a cardiac lead within the right atrium of the heart. Medical device engineers want to simulate 10 heartbeats. In each one, a different lead is used, changing the stiffness and length parameters to explore the design space. If we could only understand the differences that show up in the results, then we could design leads that are more effective and last longer. BentoBox is an interactive virtual reality technique designed to address this hard problem, which is known in the visualization research community as a form of ensemble visualization. Inspired by the artfully arranged bentos used in traditional Japanese cuisine, each data instance is assigned a column. In this example, we have 10 columns, one for each of the simulation runs. The first 3 are for the shortest leads, then the medium lengths, the longest, and finally one extreme case. The top row of the box is zoomed out to show the entirety of the data. We can grab the visualization and reorient it to see different views. But what is most useful for making comparisons is to zoom into the data, selecting a sub-volume of interest. This adds a new row and automatically recenters the visualization. Additional subvolumes can be added, starting either from the original overview or from an existing subvolume, and each can be adjusted to set up a useful comparison. Here is the volume of interest where the lead attaches in the appendage. Here is the primary vortex formed in the atrium. The view settings for each row are the same. Data visualization parameters are adjusted using a design palette. A different variable can be selected. Or alternative color maps can be applied to highlight the flow rather than the wall stress. In this way, scientists can organize a side-by-side visual comparison that highlights differences in both flow and stress data across multiple supercomputer simulation runs. The user interface is designed for 3D bimanual interaction. The non-dominant hand grabs and reframes the visualization, either individual views or the entire BentoBox widget. The dominant hand creates new subvolumes of interest when reaching into the data, or when standing back, it controls navigation. A click with a laser pointer zooms into a single view, or by sweeping out a selection, zooms into a larger portion of the BentoBox. Clicking the laser behind your head goes back. It is possible to animate the display. This is useful as an overview, but it can be difficult to make detailed comparisons with so much motion. So the technique also includes an interactive timeline widget. Scientists scrub through time interactively, or add and adjust additional columns to create side-by-side comparisons of different time steps. Here we see several time steps within a single heartbeat. These are all for a simulation with a 112 mm lead length. Using the design palette to show a second data instance, we can compare with a 116 mm lead length. The software runs in both large-scale VR environments and commodity VR headsets such as the HTC Vive. The accompanying paper describes a series of data sampling and computer graphics algorithms that make it possible to display this ensemble of more than 30 gigabytes of data at interactive VR frame rates. The core BentoBox visualization and interaction technique generalizes to any 4D data ensemble, but the research was driven specifically by the medical device design problem described here. In early use, scientists and engineers have used BentoBox to move from data to knowledge, confirming expected trends and developing new insights and hypotheses through exploratory visualization.